Hello and welcome again. We are here in Boulder, Colorado, the United States of America, where we visit NOAA, or the National Oceanic and Atmospheric Administration. In the following conversation, we're going to learn how the world's temperatures have risen faster than predicted. However, this is not meant to be a threat, but it's meant to be a call to everybody to do something. The information provided here help people make adequate decisions, either economic or social ones. Upon arrival, we met Dr. Schnell, who is an atmospheric scientist in the U.S. National Oceanic and Atmospheric Administration. The same agency does the weather forecast and conducts research on the atmosphere and climate.
My job is to run an organization that collects air around the world and looks at this air because the composition of the atmosphere is changing. More sunlight is being held in the atmosphere, and this more sunlight warms the atmosphere, which changes climate. Climate has changed many times. We've actually gone through 4 major evolutions of the climate where it got very, very hot and very tropical around the world, and then it went back into an ice age, and now. But in the current time, these cycles used to go for a million years. Now we are taking that same cycle and making it in 200 to 300 years. And that is what is difficult. The change is going to be so fast that many animals will not be able to adapt. Many plants will not be able to adapt. It takes a longer time period, or other plants and animals will come in.
This clearly shows the rise of temperatures. The blue colors represent the cooler temperatures, and as they rise, the color changes and become yellow and ultimately red. These are the temperatures in the 1870s, then from 2000, and in less than 200 years, those will be the temperatures if we keep on dumping the same amount of CO2 in the atmosphere.
To make a simple analogy of how this works is that if you are laying on a bed in a cold night and you have a thin blanket, to keep warm, you go and get another blanket and put it on you. And this blanket is exactly the same as carbon dioxide molecules. The carbon dioxide collects in the atmosphere in a very thin blanket, and this thin blanket holds the heat that you produce, or holds the heat that the sunlight produces after it hits the surface and warms the air. So as you add another blanket, and soon you have 4 blankets, you'll be very warm. And that's exactly what is happening in the world's atmosphere. We are adding more and more blankets of CO2 as we burn all of the oil. If you burn 1 liter of gasoline, 1 liter weighs a kilogram, and you burn 1 liter, you produce 4 kilograms of carbon dioxide. And that carbon dioxide will stay in the atmosphere for at least 100 years, and in some cases 1,000 years. All of the world's air is as thick as a hair on the relative of this globe. When you fly in an airplane to come to the U.S., 95% of all the world's air mass was beneath you in the plane. So there's very, very thin air. That is why when we burn fuel, and you would think that it goes away and you'll never see it again, but it's going into a very thin layer of the atmosphere.
The climate change phenomenon is demonstrated by the Science on a Sphere system that uses computers and video projectors to display planetary data onto a small sphere analogous to a giant animated globe. Researchers at the National Oceanic and Atmospheric Administration developed Science on a Sphere as an educational tool to help illustrate Earth system science to people of all ages. Animated images of atmospheric storms, climate change, air pollution or greenhouse gas emissions, air traffic or airline flights, and ocean temperatures are among other illustrations shown on the sphere. That technology is used to explain what are sometimes complex environmental processes in a way that it is simultaneously intuitive and captivating.
The common perception of climate change is that it's going to get really hot and you can feel it and we'll sweat more. That may not be true because the temperature of the globe will only go up on average 2 to 4 degrees centigrade at the most. Plants are very sensitive to temperature change, as are insects. So as you warm the earth even just a little bit, say a degree, the mosquitoes can expand. Tsetse fly can expand. Crops are very, very sensitive to temperature. Some crops will grow better in sub-Saharan Africa, Niger, Mauritania in there. It will get drier, so people will be moving farther south probably to get away from the dryness. Some areas in the Congo, it will get much warmer, more rain, rivers will rise, trees will grow. I don't know in your country, I haven't looked too close, but there probably tea will grow higher on the mountains, coffee will grow a little higher, so you'll be moving agriculture up. Maize may not grow quite as well, and that's a very important crop. And you'll see probably at some point the fish population's changing because the lakes are going to get warmer. So these are the little changes that will be. It'll be in food, vegetation, disease, and animals, and water, not in the temperature you feel. And those are the important things because it affects life, welfare, and food. And those are very subtle issues and are going to be very difficult if we don't plan carefully.
Thorough planning is important, but it is difficult to plan when what is going to happen remains unknown. Therefore, keeping the level of information high is crucial for that matter. It is also important to know if small countries such as Rwanda can contribute to the decrease of greenhouse gases emission. Rwanda is gentle on the atmosphere given its size as well as other factors such as policies and its economic status. However, the changes on the bigger picture in terms of vegetation, diseases of people and cattle, as well as food stress will have a direct impact on its population. Hence, the need of using efficiently the available energy sources.
The more efficient you are and the better planning you have and the better land use you have, individually your country will be much better off. Globally, if the US, China, and the European Union cut their production of CO2, then the effects won't be as great, the heat effects. And that's very important for these countries to do it. If we start cutting back now, it won't get so hot. But we cannot stop climate change now. Even if we stop burning all fossil fuels today, we would still have effects for 50 to 100 years because that carbon dioxide, the blanket is already on top of us. And to take that blanket off takes a very long time. But can you imagine what we have to do in our society to stop that? It's incredible. Most people want to raise their living standard. Raising a living standard means that you eat better, you live in better housing, and you have better transport, and you have refrigeration, and you have lights at night. Every one of those take a lot of energy. You probably ship flowers to Europe, at least in Kenya, that's one of their bigger exports. They fly flowers that they grow in the Rift Valley all the way to Europe every night so the Europeans can have fresh flowers the next day. So we have this huge transportation system that depends on fossil fuels, and it's going to be very difficult to change. We could make it more efficient, but I don't think we'll ever stop that. If we do, commerce will stop. A lot of us will freeze. So it's going to be very hard. Solar radiation will help. Solar power and wind power will help a lot, and nuclear power will help a lot. But for anyone to say that we can stop producing CO2 even in a short time is not realistic.